Welcome to Day 61. Today, we're going to talk about a really elegant idea in word embeddings called GloVe. It's short for Global Vectors for Word Representation. So, you've probably seen this famous example of word math before. King minus man plus woman equals queen. It feels a bit like magic, doesn't it? How on earth can a computer learn such an abstract relationship? How can a machine possibly grasp concepts well enough to perform this kind of conceptual arithmetic?
Well, it's not magic. It's actually a very clever use of statistics. And by the end of our time here, you'll get the simple, powerful insight that makes it all possible.
All right, let's dive into that core idea. The big insight behind GloVe is that meaning isn't just in the words themselves, but in the ratios of how often they appear together across a massive amount of text.
To really build our intuition, we'll borrow an example straight from the original paper. Let's think about two words, ice and steam. We know they're related, but also opposites in a way. So how could we get a computer to understand that relationship mathematically?
Okay, let's look at some data. We can count how often other words show up near ice versus near steam. Naturally, the word solid appears with ice a lot, and gas appears with steam a lot. But then you have words like water, which is related to both, or fashion, which is related to neither. The raw probabilities alone are kind of noisy, but look at that last column, the ratio. This is where the insight is. For words that really define the difference, like solid or gas, the ratio is either really big or really small. For words that don't distinguish them, the ratio is close to 1. That ratio is the clean, powerful signal the model is looking for.
And this is the central thesis of the entire model. The creators figured out that the best way to learn about meaning wasn't from the raw counts themselves, but from the ratios of those counts. It's a simple idea, but it was a huge step forward.
So that's the intuition. Now, how do we actually build a model that uses this idea? Let's get into the technical grounding.
First things first, the model starts by building a massive co-occurrence matrix from a huge amount of text. You can just picture it as a giant spreadsheet. Every row is a word, and every column is a word, and each cell simply holds a count of how many times those two words appeared near each other. This one matrix captures all the global statistics the model needs.
The learning process itself has 3 key parts. 1, the goal is to create word vectors so that when you take their dot product, you get something close to the logarithm of their co-occurrence count. 2, the method is basically a regression model that tries to minimize the error between its prediction and that actual value. And 3, this is the really clever part. It uses a special weighting function. This function tells the model to pay less attention to word pairs that are super common, like the and is, and also to ignore pairs that are extremely rare. This helps it focus on only the most meaningful relationships.
Now, to really appreciate GloVe, it helps to know what came before it. There were basically 2 big approaches. You had global methods like LSA, which looked at the entire corpus at once. They were good with stats, but not so great at those word analogy tasks. Then you had local models like Word2Vec. They were amazing at the analogy tasks, but they only ever looked at a small window of text at a time, so they missed the big picture.
GloVe was designed to be the best of both worlds. It uses the global statistics, just like the first camp, but it's specifically trained to produce the kind of vector math that made the second camp so good at analogies.
Okay, so we've got the core idea and a high-level view of how it's built. But why does this matter for you, as a practitioner, today?
But for a long time, GloVe embeddings were a foundational piece for a huge range of NLP tasks. We're talking everything from text classification and search engines to much harder problems like named entity recognition and even machine translation. For instance, think about a search engine. GloVe helps it understand that a search for large American car is conceptually very close to Ford pickup truck, even though the actual words are totally different. That ability to grasp meaning beyond keywords is incredibly powerful.
So if we had to boil it all down to one sentence, it's this. GloVe creates word vectors by directly modeling the ratios of word co-occurrence probabilities across an entire corpus.
And that leads to our key takeaway. GloVe teaches us a beautiful lesson. Sometimes the deepest insights aren't in the raw data points themselves, but in the relationships between them. And that's an idea worth remembering.